everything you think you know about the Megalodon might be wrong. For decades, scientists believed this prehistoric shark looked like a gigantic version of the great white shark, a terrifying predator about 15 meters long, an unstoppable hunter that ruled the oceans millions of years ago. But new research has completely changed that picture. Because according to recent studies, Megalodon may have been far larger, far stranger, and far more powerful than anyone ever imagined. We're not talking about a slightly bigger shark. We're talking about a predator that may have reached 24 meters in length, rivaling the size of the blue whale, the largest animal alive today. But the real shock isn't just its size, it's that the Megalodon we've been picturing for decades may never have existed at all. The famous giant great white version you see in documentaries, movies, and museums might actually be completely wrong. And the fossil that revealed this truth was discovered in a place scientists had already studied for years. But they missed one crucial detail, and once researchers finally noticed it, the entire image of Megalodon changed. But before we uncover that discovery, make sure to subscribe if you enjoy videos about prehistoric animals and the mysteries of the natural world. Because this story begins more than 350 years ago, with a discovery that helped create modern paleontology, the discovery that started the mystery. In 1666, two fishermen caught a large shark off the coast of Livorno. At first, the catch didn't seem unusual. Large sharks had been seen in the Mediterranean before, but the shark's head was sent to a Danish scientist named Nicola Steno, who was working in Florence at the time. When Steno examined the shark's teeth, he noticed something fascinating. They looked identical to strange, triangular stones that people had been discovering in rocks for centuries. These stones were called tungstones. For generations, people believed they were the fossilized tongues of dragons or giant snakes. Some even wore them as protective charms. But Steno realized something extraordinary. They weren't mythical relics, they were ancient shark teeth. And that discovery changed everything. Because it meant rocks weren't just lifeless material. They were layers of history, preserving the remains of animals that had lived millions of years ago. Soon, scientists around Europe began examining similar fossils, and again, they found enormous triangular teeth. Teeth that clearly belonged to a shark far larger than any living species. That mysterious predator would eventually be named the Megalodon. But there was one problem. Those massive teeth were almost the only fossils scientists had, and that meant reconstructing this prehistoric giant would require a lot of guesswork. The tooth problem. Unlike dinosaurs, sharks almost never leave behind complete skeletons. Their bodies are made mostly of cartilage instead of bone. Cartilage is flexible and lightweight, which helps sharks swim efficiently. But it also decays quickly after death, so when sharks die, almost nothing remains, except their teeth. And sharks produce a staggering number of them. At any moment, a large shark may have hundreds of teeth in its mouth. When one tooth breaks or falls out, another moves forward to replace it. This conveyor belt of teeth never stops. Over its lifetime, a shark can go through tens of thousands of teeth. But the Megalodon took this to an extreme level. Scientists estimate that Megalodon had about 276 teeth at once, arranged in multiple rows. Each tooth could reach 18 centimeters in length. That's roughly the size of a human hand. And over its lifetime, one Megalodon may have shed more than 40,000 teeth. For millions of years, those teeth fell to the ocean floor. Some became buried in sediment and eventually fossilized. Today, Megalodon teeth have been discovered on every continent except Antarctica. These fossils tell us a lot about the shark's diet and size, but teeth alone can't reveal the full shape of an animal. So scientists had to imagine what Megalodon looked like, and for nearly 2 centuries, one particular theory dominated the scientific world: the giant great white theory. In 1835, A Swiss naturalist named Louis Agassiz formally described the species. He named it Carcharodon Megalodon. This classification placed the animal in the same group as the great white shark. The reasoning seems straightforward. Both sharks had large, triangular, serrated teeth designed for slicing through flesh. So scientists assumed Megalodon was simply a giant version of the great white shark. Over time, this idea became widely accepted. Illustrations and books showed a massive great white. Museum displays followed the same model. Eventually, movies and documentaries made the giant shark even more famous. But as technology improved and scientists began studying fossils more carefully, cracks started to appear in the theory. The teeth looked similar, but not identical. And those differences hinted at a much bigger story. The discovery that changed everything. In the early 2000s, researchers began comparing Megalodon teeth with those of modern sharks in far greater detail. Using digital measurements and morphometric analysis, scientists studied the exact shapes of the teeth. And what they found was surprising. The teeth of the Megalodon were not actually very similar to those of the great white shark. Their serrations were finer, their roots had a different structure, even their overall geometry was distinct. This meant Megalodon and the great white shark were not closely related after all. Instead, Megalodon belonged to a completely different lineage of ancient sharks known as the Odontoceti family. Today, many scientists classify it as Otodus megalodon. That revelation was important, but it also raised a much bigger question. If Megalodon wasn't related to great whites, then the animal might not have looked like one either. And when scientists finally examined new fossil evidence, they realized the story was even more surprising, because Megalodon might have been far larger than anyone had imagined. A predator, bigger than we thought. For decades, scientists believed the Megalodon measured somewhere between 15 and 18 meters long. Already an enormous predator. But in recent years, researchers began studying a rare fossil discovery found in Belgium. This fossil included a series of Megalodon vertebrae, the large discs that make up a shark's spine. The research team was led by paleobiologist Kenshu Shimada. By comparing these vertebrae with those of more than 160 living and extinct shark species, scientists were able to estimate the shark's body proportions. What they discovered was astonishing. Some Megalodon individuals may have reached 24 meters in length. To put that into perspective, that's about the same length as a blue whale, and it may have weighed around 90 tons. That would make Megalodon not only the largest shark ever discovered, but one of the largest predators in Earth's history. But size wasn't the only surprise. When scientists studied the proportions of its body more carefully, they realized Megalodon probably didn't look anything like the giant great white we've imagined for decades. What Megalodon actually looked like. For years, Megalodon was depicted as a thick, muscular predator, a massive version of the great white shark. But newer research suggests something very different. Instead of a bulky hunter, Megalodon may have had a sleeker, more streamlined body. Some scientists believe its shape resembled a lemon shark more than a great white, with a shorter snout and longer fins. This design would have allowed the giant shark to move through the ocean more efficiently. Large animals often evolve streamlined bodies because it reduces drag in water. Even the enormous blue whale relies on a similar hydrodynamic shape to travel vast distances across the oceans. This sleeker design may have helped Megalodon grow larger than scientists previously believed possible, but if adult Megalodons were massive, their babies were even more surprising. The terrifying life of baby Megalodons. Most shark babies are tiny. Some are only a few centimeters long when they are born, but newborn Megalodon were completely different. Scientists estimate they were already 3.6 to 3.9 meters long at birth. That's roughly the size of an adult great white shark. And they reached that size before they even entered the ocean. Inside the mother's womb, Megalodon embryos likely practiced intrauterine cannibalism. The strongest embryos would consume unfertilized eggs. Sometimes they even devoured their siblings. This brutal survival strategy ensured that only the strongest offspring were born. By the time they emerged into the ocean, these baby sharks were already powerful predators. For millions of years, this strategy worked perfectly, but eventually, even the most dominant predator can disappear. And around 3.6 million years ago, the giant shark vanished. The extinction mystery. The extinction of the Megalodon remains one of the biggest mysteries in marine science. At first, researchers believed colder ocean temperatures during the Ice Age caused the species to die out. But more recent studies suggest that climate change alone probably wasn't the main cause. Instead, the real problem may have been food availability. During the late Pliocene epoch, many large marine animals began disappearing. Fossil evidence shows that more than half of large marine mammals went extinct during this time. These included several species of whales and dolphins, and those animals were some of Megalodon's most important prey. Without a steady supply of large marine mammals, the giant shark may have struggled to find enough food. At the same time, the oceans were changing rapidly. New predators were evolving, and one of them may have played a crucial role in Megalodon's downfall. The great white shark. Compared to Megalodon, great whites were smaller and more agile. They required far less food to survive. In a world where prey was becoming scarce, that smaller size may have been a huge advantage. Over thousands of years, the balance of power in the ocean shifted, and eventually the giant shark disappeared from the fossil record. But some people believe the story might not end there. Could Megalodon still be alive? Every few years, news stories appear claiming that the Megalodon might still exist. People report seeing enormous shadows beneath the ocean surface. Some documentaries even claim the giant shark could be hiding in the depths of the Mariana Trench, the deepest part of the ocean. It's an exciting idea, but scientists say it's extremely unlikely. A predator that large would need enormous amounts of food to survive. And the deep ocean simply doesn't contain enough prey to support a 24-meter shark. There's another problem too. If Megalodon still existed, we would almost certainly find evidence. Massive bite marks on whales, giant teeth washing up on beaches, or encounters with modern predators like orcas. But none of that evidence exists, which strongly suggests the giant shark truly went extinct millions of years ago. But even if Megalodon is gone, its mystery is far from solved. Despite thousands of fossil teeth, scientists have never discovered a complete Megalodon skeleton. And until that day comes, the true appearance of this prehistoric giant may remain one of the greatest mysteries in paleontology. Because somewhere beneath layers of ancient rock, there may still be fossils waiting to reveal the real Megalodon. And when that discovery finally happens, everything we think we know about the ocean's greatest predator could change again. If you made it this far in the video, comment the shark emoji below. And I'll see you in the next deep dive into Earth's most fascinating creatures.